Let's unpack a new paper titled On Limitations of the Transformer Architecture. What's the core idea here?
The heart of the paper is about exploring why large language models, particularly those built on the transformer architecture, sometimes produce outputs that don't match their training data, often called hallucinations. It suggests that there are inherent limitations in how transformers process information, which can lead to these unexpected results. They examine a core aspect of human reasoning, function composition, and how transformers have a hard time reliably doing it.
Function composition, could you break that down a little further? How is that relevant to language models?
Absolutely. Think of it like this. You have two relationships, like mother of and profession of. Function composition is about combining these relationships to answer questions. For example, if Helen is John's mother and Helen is a doctor, then what is the profession of John's mother? Now, it seems straightforward for us humans, but this is a task that can trip up transformer models, especially as the range of possible relationships expands. Plus, this function composition underlies a lot of language understanding, including how we understand words that reference other things in the context of a sentence or paragraph.
So, how did the paper go about proving these limitations in transformers?
They used a concept from theoretical computer science called communication complexity, imagining a scenario where different parts of the input are known by separate entities who can communicate to solve a problem. They demonstrated that for a transformer to correctly compose functions, an unrealistic amount of information would need to be exchanged. The paper highlights the role of the softmax computation in distributing information within the transformer layer, contributing to the challenge of function composition.
That's interesting. Are these limitations purely theoretical, or are they showing up in practical applications as well?
That's a great question. While the mathematical proof is focused on a simplified model of the transformer, the paper does discuss signs of these limitations appearing in more complex, real-world language models, particularly in how they handle tasks that involve multi-step reasoning or composing longer chains of functions. They present anecdotal evidence of this in the appendix, with prompts given to several large language models with mixed results.
You mentioned chain of thought prompting, or COT. Isn't that supposed to enhance the reasoning capabilities of LLMs and help with issues like hallucinations? Does the paper touch on COT's effectiveness against these compositional challenges?
Yes, COT has been shown to improve the performance of LLMs on various tasks. The paper acknowledges that a well-structured chain of thought can mitigate some of the issues with function composition by breaking down complex questions into simpler steps. However, they also point out that if we're talking about a cascade of many functions, not just a two-step composition, the length of the COT prompt could become a limiting factor. There's a trade-off in the number of steps and the amount of information that needs to be processed.
Besides communication complexity, did the paper discuss other theoretical lenses through which to view transformers' limitations?
Yes, they did. They discuss the computational complexity of transformers and how they relate to problems like evaluating arithmetic circuits and solving logic puzzles, which also can reveal limitations based on widely accepted complexity assumptions. These problems share similarities with the compositional tasks that transformers tend to struggle with. The authors note the connection between a transformer's need for logarithmic memory and the increasing difficulty it experiences as the depth of these compositional tasks grows, which is also backed up by empirical findings of other researchers.
So these limitations are tied to the core architecture of the transformer? Are there ways to redesign the transformer layer to bypass these limitations?
Redesigning the transformer layer to overcome these limitations presents a significant challenge for future research, as hinted in the paper. The paper suggests that future research could explore alternative approaches to the softmax computation or consider operations that are not commutative or associative. However, as they caution, simply sidestepping a limitation found in a mathematical proof does not guarantee a practical improvement, So further research and experimentation is necessary in this space.
Thank you for discussing this.